Take a look at rotations today. Rotations, of the transformations we've done so far at least, are probably the trickiest to do. So you have to, we'll just kind of try to give an introduction here with this video, and then we'll talk more about it in class. The objective is I can verify that an object has been rotated, reflected, or translated by comparing the lengths of lines and line segments from one object to the other. Our vocabulary terms today, first one says a transformation in which a figure is turned about a fixed point. That is a rotation, a turn. A fixed point about which shapes move in a circular motion to a new position. That's called the center of rotation. Our center of rotation, almost always when we're working with rotations, will be the origin. So it's going to be we're going to rotate things around the origin there, which is going to make things a little bit easier for us. Just a couple of things real quick before we get to this little activity we're going to do. You do need some paper, and you'll need some scissors because we're going to be tracing and cutting here again today. But just a quick thing about rotations. We measure rotations in degrees, the same degrees that we use to measure angles. So just a quick review about angles and degrees and how all that stuff works. So let's say I've got this is technically a ray because it's only got an arrow on one end. Technically I've got a line here or a ray that's pointing straight up, and I'm going to rotate that, let's say 90 degrees, so that it's this way. If it's going flat like that, that's a 90-degree turn right there. It's a 90-degree angle, we could say as well, right? If I have a ray that's pointing to the left, and I rotate it all the way, not till it's just pointing straight up, but all the way so it's pointing to the right, if I went from here straight up, that's 90, and then another 90 till it lays flat again, making a straight line. That's 180 degrees. Okay, 180 degree rotation there. So that's going to be important for us to know as we work with these rotations today. All right, this says trace triangle ABC onto a piece of paper and cut out your traced triangle. So I would like you to go ahead and line up one corner of the triangle, excuse me, one corner of the paper with the origin right there. And you've got an edge that matches up with the y-axis and an edge that matches up with the x-axis. And that's going to make things a little bit easier because we're going to use this piece of paper for something else, so I don't want you to completely ruin it here. So draw a line to sketch and trace that side and this side right here to make that triangle that we see. And if at any point I get a little bit ahead of you here, you can always pause the video, but I'm going to cut this out. There we go. I'll set this paper aside. I'm going to use it again later, but for now, we don't need it. And let's see, get this placed in here just right. Okay. It says rotate your triangle 90 degrees counterclockwise about the origin. Counterclockwise. So we've got the way a clock moves, which would be this way. And we have opposite the way a clock moves, which would be the other way, which is counterclockwise. So we're going counterclockwise about the origin. The side of the triangle that lies on the x-axis right here should now lie on the y-axis. So you see we're going to rotate this side. Now it's laying flat. We'll be pointing straight up. So I'm going to rotate this. I'm going to try to hold my triangle in place on the origin right there and rotate this 90 degrees. Hold that in place there or not. Okay, there we go. So it's going to look like this. So that side that was right here is now pointing straight up. We rotated 90 degrees. So I'm going to hold it in place right there for a minute. And it says, sketch the image of the rotation. Label the images of points A, B, and C as A prime, B prime, and C prime. Well, A didn't move at all. It was right here. It was on the origin. Anything on the origin is not going to move. That's A prime. B, see, was 2 units away from the origin here to the right. Now it's 2 units pointing straight up. So that's going to be B prime. And then we had C that was right here, rotated to right there. That's C prime. So go ahead and sketch that in here. And now we have the image of that after it's been rotated 90 degrees counterclockwise. says describe the motion modeled by the rotation. Well, we had to rotate 90 degrees counterclockwise about the origin. All right, this next section is going to just kind of, again, help us to see the steps for a rotation here. It says the figure shows triangle ABC. Graph the image of triangle ABC after rotation 90 degrees clockwise this time. So we're going to go 90 degrees clockwise. Rotate the figure clockwise from the y-axis to the x-axis. So this is making the point here that right now it's kind of splitting the triangle in half with the y-axis. When we rotate it 90 degrees clockwise, it's going to be, so it's splitting the triangle in half with the x-axis. So it says point A will still be on 0, 0. Anything on the origin will stay 0, will stay at the origin there, so it's going to be 0, 0. But point B is 2 units to the left of the y-axis right now. So point B prime will be 2 units above the x-axis. When we rotate this, so it's 2 units away, it's going to be 2 units away here. And it's going to end up right there. Point C is 2 units to the right of the y-axis. So you see right here, 2 units to the right. So point C will be 2 units below the x-axis when we rotate that. So go ahead and draw that in there. So the last part that says connect A prime, B prime, C prime to form the image of triangle A prime, B prime, C prime. So just one thing real quick that I want you to see with this before we move on to the back side. I can't show you this with A because A stood still, but with B, we rotated 90 degrees. So if I put a corner right at the origin, it's going to make a 90-degree angle from a line from the origin to B and a line from the origin to B prime. And then same thing with C. Since we moved C 90 degrees, should be able to fit a corner right in there, and it's going to make a 90-degree angle from C to C prime as well. So we can kind of use this to help guide our rotations a little bit. Just a piece of paper with that has a 90-degree corner there to help us make sure we get these in the right spot. Let's flip over to the back side and do a little practice back here, just a few problems. This says graph the image of the figure using the transformation given. So the first one is a rotation 180 degrees about the origin. We haven't had one of those yet. It doesn't say clockwise or counterclockwise, because if you do a 180-degree rotation, it doesn't matter. If you go clockwise 180 degrees, you're going to end up still in the same area. If you go counterclockwise 180 degrees, you're still going to end up in the same area. So it's basically going to end up across from this right here. So let's rotate these. I'm going to kind of do this one at a time. A 180-degree rotation is a straight line, right? So that means passing through the origin, if Q is right here right now, it's going to make a straight line and end up right here at Q prime. So we don't really need any help to figure that one out. But let's say for J right here, if we're going to go 180 degrees and we're going to pass through the origin, you can line a piece of paper up that has a flat edge, because this time we're making a straight line, 180 degrees, pass through the origin, and it's going to be the same distance away. See, this is on the edge all the way out here, and this is going to be on the edge as well. So we're going to go,
Gordon, are you?
Yep. So we're going to be going, I was Kenny there at the door, but that's okay. We're going to keep on going on here. We're going to pass through this point right here, and since this is on the edge, this is going to go all the way to the edge too, right there at the very end, and that's going to be J prime right there. And then we'll do the same thing with H. We've got going to pass again through the origin right here. There's H, line that up, and then through the origin. And this is going to pass right there, pass through the origin, and then right here on the end again, right there, that's going to be H prime. So if you know that a straight line is 180 degrees, it can kind of help that to create this figure. So that was the origin right there. There's Q prime. Connect these now. All right. So we were able to make that just using this piece of paper to help us guide that rotation there. All right, number 3 is a rotation 90 degrees clockwise about the origin. So this one's going to be a little trickier here, but we're going to be able to use the piece of paper again if we want to, if we need to. You can actually do without it too. Some people are just good at visualizing these rotations, but I'm trying to give you the paper to help you if you're having trouble with that. So we're going to go clockwise, which would be here. So right now, the x-axis is basically splitting this in half. It's going to be the y-axis as we rotate this that's going to split this in half. So you see how this is 1 unit away from the y-axis? When we rotate this, it's going to be 1 unit away from the x-axis right there. But to help guide us and make sure we get the right thing, we can do the same thing we did on the other side of the piece of paper. For a 90 rotation, we want to put a corner right at the origin there. And it's going to be the same units away from the origin. So 1, 2, 3. We're going to go 1, 2, 3. And that's where F prime will be. You got to make sure we're going this way with it. That your 90 degrees is there. Let's keep on going here. Let's go to B. Here, we're going to go 90 degrees and put the corner right there. Now B is all the way on the edge there, so it's going to be on the edge up here as well. So make sure the edge touches B. You got a corner at the origin. It's going to be all the way at the top up there, B prime. Let's keep going here, and we'll get M. So M is 1, 2, 3, 4. So we're going to go 1, 2, 3, 4. Right there. It's going to be M prime. And then we'll get H right here. Rotate that. Point at the corner right there. And lines up with H. It's just 1, 2 away. So 1, 2 right there. Going to be H prime. Now when we're done, we want to make sure that this looks right too. But let's go ahead and connect these. So we got this. A rotation does not change the size or shape. So it should be the same size and shape, just turned. So see how it was like this. It rotated up like that. M, M prime, B, B prime, F, F prime, and H, H prime. So all that has been rotated 90 degrees clockwise. All right, so for number 5 here, we're supposed to write a rule to describe each transformation. This is a little bit easier. You just gotta make sure you know where your starting ones are and where your pre-image and your image. So this is the one that has the prime notation. So here's your starting point. You went from Q here to Q there. Really, you only have to do 1 point, okay? So your origin is here. This is on the x-axis, and this is on the y-axis. So it didn't go a whole 180 degrees. It went 90 degrees. So this is, the rule is rotation. We know we went 90 degrees. And what direction do we go? Is this clockwise or counterclockwise? It could be clockwise. Oops. Clockwise, about the origin. We gotta make sure we say what the center rotation is. So that's the rule there for that. All right, we'll explore, rotations are tricky, so we'll explore a little more with rotations as we get to class, we'll do a little more practice with this. But for now, that's our work with rotations.